So here's a D2 Edexcel dynamic programming problem from a table, June 2013. Before we start, there's a few things that we need to say. It's given us a bit of help. It's given us quite a bit of structure. The action is always to keep or replace at any particular state, for instance, and it started us off here in that vein. These numbers are a little bit unusual, but these numbers only occur once because unusually in this situation we're told at the end of the period they're sold off. So these numbers only occur right at the end. So we don't need to bother about them now that they're put in the table for us, thankfully. It might be a little bit more problematic to start off in that vein because there would be a number of ways in which we can do it, but they've given us a definite structure here. Before we talk about how we go about it and where these numbers come from, it is important to say with dynamic programming we must be working backwards. Even though some of the problems may work and the problems can be solved easily by working forwards, that doesn't mean to say we're dynamic programming if we do so, because there's very sound reasons why we should be working backwards. So always working backwards. The other key thing is that we're always pulling down optimum values from before. So let's just talk through these numbers here. If we're in year 4, we've got 3-year-old bicycles at the beginning of year 4. What that essentially means is that we haven't replaced them in any time before. Then if we keep them, we've obviously got 4-year-old bicycles and we're pulling down the one from before. Okay. However, if we replace them, okay, we've got 1-year-old bicycles and we're pulling down the 6 from before. Okay, now the 2 here, just for clarity there, is because if we've got 3-year-old bicycles, the income is a 2. And the 3 is that the cost, the minus, because it's a cost, of keeping 3-year-old bicycles, which is what we're doing for in this particular row here, is 3, so 3,000. And similarly, if we've replaced them, we've got new bicycles, hence the 11 here. But then, of course, we've got the cost of replacing 3-year-old bicycles for new ones, which is 9. Okay, so that's how it works. Okay, so let's just get on with it. If we have 2-year-old bicycles, we can either keep them or replace them. That's what we're doing as our action. That's the decision we're making. Okay, so if we keep 2-year-old bicycles, they become 3-year-old bicycles. However, if we replace them, they're obviously new at the beginning of year 4, and at the end of year 4, they will become 1-year-old bicycles, like that. So now let's work out the numbers. If we have 2-year-old bicycles at the beginning, which we keep, which become 3-year-old bicycles, the number we're pulling from before is the 2. Okay, the income generated from those 2-year-old bicycles will be 5. Okay, but the cost of keeping the 2-year-old bicycles will be 2. So that totals 5. So moving to the replace, which means that we've got 1-year-old bicycles at the end. That means that we're pulling that 6 from before. We will have generated an income of 11 from those new bicycles, but we will have had a replacement cost for the 2-year-old bicycles of 8. So that's 6 plus 11, 17, take away 8, which is equal to equal to 9. Okay, and the optimum of these is obviously 9. So now we can consider the state 1-year-old bicycles at the beginning of year 4, which we can keep or replace. If we keep them, we've got 2-year-old bicycles. If we replace them, then we've then got new at the beginning and 1-year-old at the end. Okay, now completing the numbers, if we've got 2, we're pulling down the 4 from before. Okay, now if we've got €1 bicycles and we've chosen to keep them, we've got a cost of 1 and an income of 8. So that's 4 plus 8, take away 1, which is equal to 11. So moving to the next row, that we've replaced our €1 bicycles with new ones. Obviously we're going to be pulling the state destination 1 from before, so that gives us a 6. If we have new, they're going to have generated an income of 11. However, these €1 bicycles will have had a cost associated with their replacement, which will be equal to 7, which gives us a total of 10, and the optimum of these is 11. So now we've completed the whole of that stage, which is year 4, and we're moving on to year 3, hence the line that's just been produced across the whole of the table, because we're now at the next stage. Now at year 3, at the beginning of year 3, we could either have €2 bicycles or €1 bicycles, which we choose to keep or replace for each one. Okay, so let's just do the first state first, which is the €2 bicycles. If we have €2 bicycles, they will become €3 bicycles. Okay, let's just rub that out from the time before. They will become €3 bicycles, and we're going to be pulling down the stage 3 from before, which is the 8. Okay, now we will have generated an income of 5, but we will have had a replacement cost of 2, which gives us a total of 11. Now considering if in year 3 state 2 that we had €2 bicycles and we replaced them, they would be new at the beginning but 1 year old at the end. So this time we're pulling down state of 1 from before, so that's the 11 from before. And then these will be new bicycles, which will generate an income of 11, but there will be a replacement cost of replacing €2 bicycles for new ones, which will be 8. So that's 11 plus 11, take away 8, which is 14. We're trying to maximize, so the 14 is our start optimal value here. So moving on to the next state, that we had €1 bicycles at the beginning of year 3. If we keep them, they obviously become €2 bicycles. We then pull down the optimum from the 2, which is our 9, and pull that down from before, put 9 in. Now if they're €1 bicycles that we haven't replaced, they will generate an income of 8, and there will be a keeping cost for those of 1. So that's 9 plus 8, take away 1, which is 16. So you're getting the feeling for this. If they're replaced, on the other hand, we will have new at the beginning, but they will then become 1 year old at the end. Okay, we're pulling down the optimum from that state from before, which is our 11. Okay, so that's our 11 is being pulled from before. We will also have an income of 11 because they're new bicycles. However, there will be a replacement cost for the €1 bicycles of 7. So that's 11 plus 11, take away 7, which is equal to 15. The optimum of these is 16, so that's the optimum one which we star. So that's stage year 3 completed. That stage is now done. Year 2, we will undoubtedly have 1-year-old bicycles. They cannot be anything else because we started at the beginning of year 1. We then choose whether to keep those 1-year-old bicycles or replace them. If we keep them, of course, they become 2-year-old bicycles. If we replace them, they were new at the beginning, so they're 1-year-old bicycle at the end. Okay, so considering the first row here, if they're 2-year-old bicycles, we're going to pull down the optimum one from before, which is 14. Okay, now the income from the 1-year-old bicycles is going to be equal to 8. The replacement cost, not the replacement cost, the cost of keeping the 1-year-old bicycles, maintaining or whatever, is going to be 1. So that's 14 plus 8 take away 1, which is equal to 21. Now considering if we replaced our 1-year-old bicycles at the beginning of year 2, we're obviously taking the 16 from the state before, because that's not our destination. Is 16, so we're pulling the 16 from before. We then have got new bicycles, so that's going to generate 11. However, they were 1-year-old bicycles with a cost to replace of 7. Adding all of those together, we get 20. So the optimum of these is 21. Okay, so that's year 2 stage completed. Year 1, there really is nothing to decide now, because we've got new bicycles. They were given to us, or by some act of God or whatever. Say this isn't an economics problem. So when we're talking about profit, we're told clearly in the question that Nigel has a new fleet of bicycles, so there is no cost associated with those new fleet of bicycles. Okay, we're obviously choosing to keep those new bicycles. Okay, and they will become 1-year-old bicycles, and we pull down the 21 from before. Okay, and they will make a profit of 11, which is 32. Okay, now we've nearly finished this problem. That exit in it, the actual final row is almost the beginning and end are obviously the least easy to come up with. Thankfully they did the beginning for us, and then the end is more difficult. The fact that we start off with the new here, and there's actually no choice as such in year 1. We're just going to go with our new bicycles and make our money, for our £11,000 income from them. And then the decisions actually start at the beginning of year 2, whether to keep or replace. So now we work backwards. Let's put a star value on there. Now we work backwards to find our optimum. Okay, so we're looking at our destinations. We can see it's gone from here. We've got a 1 here. Okay, which then we pick up the optimum from state 1 before, which is 2. Okay, so we go to the 2 before. So that's the 1 to replace. And then the replacement, we go to the 1 from before, which is the 11. State 2, and then here, that goes to there. Okay, so in the first year, we obviously keep them. In the second year, we obviously keep them. In the third year, we replace them. And in the fourth year, we choose to keep them. And that is it. And the final cost is this, which is £32,000. And that's the problem done.